Hello everyone, my name is Sundale and in my presentation I want to talk about biomems in healthcare. So what is the definition of MEMS or what is considered to be MEMS? Micro electromechanical systems or MEMS can be defined as the technology of microscopic devices fabricated using the technique of microfabrication, and they are used to immediately report the physical properties of their environment or to perform a certain kind of action when they are signaled to do so. Now, these devices have many useful applications in many areas because of their potential cost advantage when they are produced in huge batches and their ability to measure different types of motions such as acceleration, momentum, and even pressure, etc. If semiconductor microfabrication was seen to be the first micro manufacturing revolution, then MEMS is the second revolution. For example, you find MEMS technology in motion sensors for smartphone-based navigations. You find MEMS technology in airbag deployment in automobiles. And in this presentation, I want to focus on the application of MEMS or biomems technology in healthcare. Biomems devices are made just like how the integrated circuit or IC are made using the batch fabrication techniques. As a result, they can be made at a relatively low cost but with high level of functionality. In general, biomem sensing element is mounted on the plastic or ceramic base with a plastic cap covered. It is very highly unlikely for the body to reject biomem's implants because of the human body does not recognize silicon as a foreign materials, so it does not start a rejection reaction sequence. There are two different type of biomems. Um, well, they can be divided into different categories: sensor and actuator. Biomem sensors are used to report the physical properties of their environment, which is the human body in this case. For example, it can be used to measure blood pressure or glucose concentration. The other type is the actuator. Now, this type of MEMS are used to perform on actions in the patient's body, such as positioning, regulating, pumping, only when they are signaled to do so. Biomems have many different applications in healthcare. One of the applications is to quantify bodily functions. For example, the largest market for MEM sensors in the medical field is a sensor that is used to monitor blood pressure of patients in intensive healthcare. Some biomass implants can be inserted into the body and moved to the specific place near the heart to keep track of the heart rate. Biomems devices could also be used to analyze the concentration of oxygen, carbon dioxide, calcium, potassium, and glucose in a patient's blood. Another function of biomems is called microfluidics for diagnostics. In countries where there's little or no hospital access with the equipment to perform diagnostics, bodily fluids such as blood or saliva could be utilized in biomems devices with microfluidic functions to determine medical illness on the spot. Biomems devices could also be used to determine abnormal brainwave behavior, abnormal heart rate, or respiratory conditions by the components of the saliva. Another application is replantation. Biomems technology are used in microsurgery for the reattachment of limbs and other parts of the body. The restoring of blood flow to the arteries and veins are only possible with the use of micro tools. Next, I want to talk about the biomems devices that are currently on the market. I'm sure most of us have heard about the cochlear implant because it has been in use since 1981. It was originally invented by Dr. William House. And this device provides a set of sounds to a person who is moderate to profoundly deaf because of inner ear damage. It works by replacing the function of the damage in the ear by converting digitally coded sound from the processor into electrical impulses and then send them to the brain. Microsurgical tools are also on the market. In recent years, they have been shrinking because there's a lot of talk going on about implementing nanosurgical tool, but the current microsurgical tools still get a job done. For example, the MEMS-based microforceps uh, from the visual aid could grab object from 15 micrometer in size down to 100 nanometer in size. And again, these tools can be made with the batch fabrication techniques, so the costs are low. Next, I want to talk about the future of biomems. First of all, I wanted to talk about the glucose sensing contact lens by Google. In April of 2014, Google received a patent for its glucose sensing contact lens. Like normal contact lens, its primary purpose is to improve the vision of the users and dropping the need to use glasses. However, these contact lenses could also be used to measure the glucose level in the tear fluid and then indicate the level of glucose to the users with a built-in LED, giving the users the power to take direct actions. On the side note, all electronics components of the lens are designed to be placed outside of the pupil and the iris to prevent damage. So far, Google has built a prototype of the contact lens, and the device is able to return one reading per second. The feedbacks from the lens can be transferred wirelessly to external devices such as smartphones, smartwatches, using radio frequency identification technology. However, there are doubts on the practical aspects of the contact lens because a few studies have shown that there are not a strong correlation between tear fluid and glucose level. But at this moment, this device is still in the testing phase. Modifications will be made, and it provides more than just a pen-free alternative to the conventional methods of measuring glucose level, because its data could be also be used by the user's physicians to analyze glucose level over a long period of time. Another Biomems device that I want to talk about is the X Patch by X2 Biosystems. As of recent year, concussion in sport has become a major topic as more studies have shown. Athletes who experience concussions from head injuries and subconcussive hits are more likely to face neurological problems later in their life. The X-Patch, created by X2 Biosystems, has the capability of measuring and keeping log of direct impacts to the head. The patch is to be applied on the mastoid part of the temporal bone of athletes, which is the area behind the ear. In 2014, the Saracens FC rugby team wore the patch in the game against the London Irish. The players were assessed before the game, following concussion protocols. During the game, the X-Patch sent live feedbacks to the team's physicians for them to determine the severity of the direct hit to the head. The X-Suba System company is currently working professionally with leagues such as the NFL and the NHL to implement the X-Patch, as concussion in professional sport is drawing more and more attention. Next, I want to talk about Professor Junseok Chae's research. Now, this research hits very close to home because Professor Junseok Chae is from ASU's Electrical Engineering Department, and he is currently working, researching on a wireless neural implant. As you can see from the visual aids, this device is many, many times smaller than the size of a 1 cent coin, with the sensor mounted on a silicon base. And the coolest thing about this device is how it is powered by microlithium microbial fuel cell. The cell contains the geobacter, which is an exoelectrogenic bacteria that can break down ethanol to produce excessive electrons. Currently, this device power density is measured at 2.3 milliwatts per centimeter square, which is very good for microbial fuel cell. The other visual aid shows the compound action potential, or CAP, generated in the nerve from reference electrode, and this wireless demodulated CAP from the neural implant. You can see the wireless signal sent back from the implant corresponds to the generated CAP. Now, this design has great potential benefits to diagnose or to prevent neurological disorders such as stroke and dementia. To conclude the presentation, I want to talk about the future of biomems. In the future, it's very likely that biomems devices will become a permanent inhabitant of the human body. The sensor, the actuators can keep track of the body and log the data and then send it directly to the physicians to be analyzed. At this moment, human bodily functions such as hearing have been replaced by biomems devices. It's not difficult to predict other senses such as sight or touch will be replaced as well. Right now, we are at the dawn of biomems age. In the future, these little chips will become an integral part of our life, and without doubt, raising many ethical questions. Personally, I believe that there is no limit to how far these devices can enhance us. But no matter how you perceive biomems, this technology is growing and glowing. We are slowly integrating them into our lives with or without ethical judgment, to make ourselves stronger, to make ourselves better equipped against diseases. Thank you for watching my presentation. I hope you enjoyed it.